In this video, we're looking at the double angle formulas for sine 2 theta and cos 2 theta. Now, for the cos 2 theta one, to get from here to here, it's actually using the identity sine squared theta plus cos squared theta equals 1. So to get to this one here, we're substituting cos squared theta equals 1 minus sine squared theta. So by putting that expression into there, we get 1 minus sine squared theta minus another sine squared theta. So that's why it's 1 minus 2 sine squared theta. Now to get from this one to this one, we're substituting the fact that sine squared theta equals 1 minus cos squared theta. So for that one, if I go from here, that will then equal cos squared theta minus 1 minus cos squared theta, which equals cos squared theta minus 1, but minus times a minus is a plus, and then cos squared theta. So cos squared theta plus cos squared theta is 2 cos squared theta, and then we've got the minus 1 there. So that's how the three versions of the cos 2 theta formula are related. And for instance, we can use these by working out sine 90 is 2 times sine 45, so half of 90 is 45, and cos 45, so we're using this first one here. And then that becomes, okay, so 1, because sine 90 is 1, 2 times sine of 45, 1 and root 2, cos of 45 is also 1 and root 2, and if you simplify that, you get 2 on 2. So this is just an example to show that this formula does in fact hold. And then here, according to this, cos squared pi minus sine squared pi, well, cos pi is negative 1, squared would be 1. Sine of pi is 0, squared would be 0, so 1 minus 0 is 1. But using this formula here, the double angle formula for cos, you get cos 2 pi, and cos of 2 pi is 1, and therefore you get 1 equals 1, which is also correct. So they're just examples, numerical examples, to show you that these formulas do in fact hold. Okay, so for question 1, if sine theta equals 3 on 5, where theta is between pi on 2 and pi, find the value of sine 2 theta without using a calculator. So if you're doing the analysis course, you'll know you have a non-calculator paper, so it's important to be able to do this without a calculator. So sine of 2 theta is, according to our formula, 2 sine theta times cos theta. Now we already know what sine theta is, it's 3 on 5. So what's cos theta? Well, to work out the numerical value, we can use a right angle triangle. Now, if this is theta, and you can make either angle, the top one or the side one, theta, then according to sine theta equals 3 on 5, the opposite side would be 3, and the hypotenuse would be 5. That's because of, remember, sine is opposite over hypotenuse. Okay, so what's this missing sign? Now, hopefully you already know that it's 4 using Pythagoras, but if you're not sure, let's say we label it x. 5 squared equals 3 squared plus x squared. So 25 equals 9 plus x squared. Minus 9 to both sides, you get x squared equals 16. And square root, x is 4. So that means cos theta, according to that, is, if this is 4, adjacent over hypotenuse is 4 on 5. Okay, however, there's one little bit that we haven't considered yet. The fact that the theta is between pi on 2 and pi. So let's just draw a unit circle. Alright, so where's pi on 2 and pi? Pi on 2 is here, pi is here. So we're actually in this quadrant. And cos is negative in that quadrant. Therefore, cos theta is actually negative 4 on 5. So here we times it by negative 4 on 5. So to do that, 2 3s are 6, 6 4s are 24, so negative 24 on 25. Now, another thing to think about is if this angle theta is an obtuse angle, then if we were to double it, we would probably end up either in the C quadrant or the T quadrant. So 2 theta would be either in T or C, which means sine would be negative of 2 theta. Therefore, it makes sense that we get sine 2 theta is a negative number. So just something to think about there. Okay, for question 2. Given that sine alpha is 7 on 25 and cos alpha is negative 24 on 25, find sine 2 alpha and cos 2 alpha. Okay. Sine 2 alpha, we've just done one just like it, is 2 sine alpha cos alpha. So we can just substitute them right in there. We get 2 times 7 on 25 times negative 24 on 25, which is, this one I'll need a calculator for. So we'll get 14 times negative 24 over 25 times 25, which I believe is 625. And 14 times negative 24. $336. So I end up getting 336 over 624. Oops, I get 625. Okay, so what's cos 2 theta? It's up to us which formula we use. We can use the basics, the cos squared minus sine squared, or we can use one of the other ones. Now I'm thinking, if this were a non-calculator paper, it would be easier to work with this fraction only. So I'm going to try using the sine one, which is 1 minus 2 sine squared theta, and see if we can do it without a calculator. So we get 1 minus 2 times 7 on 25 squared, which is 49 on 625. So we get 1 minus 2 times 49 is 98 on 625. Now this isn't so easy to do without a calculator, but at least it's not impossible. 625 minus 98. Okay. Then 61 minus 9 is 52. Hopefully that's right. So I get 527 over 625. Yep. Okay. So, but we could have, here in a test, we had a calculator access, you could have used any of the cos 2 theta formulas. All right. Now this one says if alpha is obtuse and cos 2 alpha is 2 on 5, find the value of cos alpha and sine alpha. Okay, so we know alpha is obtuse. So we know alpha would be in the S quadrant. So we know cos alpha is going to be negative and sine alpha is going to be positive. And they also said cos 2 alpha is a positive 2 on 5, which means it's in S1. So what we could do is use, let's first use the cos 2 alpha formula, but just in terms of one cos alpha or sine alpha. So for the cos alpha one, that's 2 cos squared alpha minus 1. Because we know what cos 2 alpha is, that'll be easy to solve for cos alpha because there's only one unknown. So if I replace cos 2 alpha with 2 on 5, and that equals 2 cos squared alpha minus 1, add 1 to both sides, and I'm going to get 2 on 5 plus 5 on 5 is 7 on 5 equals 2 cos squared alpha. Divide both sides by 2, we get 7 on 10 equals cos squared alpha. And then cos alpha equals, now usually when we square root both sides, we get plus minus root 7 on 10. However, we already said that cos alpha is going to be a negative because we're in the S quadrant. So therefore, cos alpha is negative root 7 on 10. So now let's have a think about sine alpha. Cos 2 alpha equals 1 minus 2 sine squared alpha. Okay, now again we replace cos 2 alpha with 2 on 5 equals 1 minus 2 sine squared alpha. I want to move the negative 2 sine squared over so it becomes positive 2 sine squared alpha. And now I'm going to move 2 on 5 over and that'll become negative like that. You didn't have to do it like that. You minus 1 from both sides, then divide by negative 2. It's up to you. That's just the way I usually do it. And now simplify both sides. 1 minus 2 on 5 is 3 on 5. Divide both sides by 2. 3 on 10. Square root both sides. I get sine alpha equals plus or minus root 3 on 10. But wait a minute, we said sine alpha was positive because we're in the S quadrant. Therefore, sine alpha is just root 3 on 10. I'm afraid you wouldn't get all the marks if you stopped here or here. Sorry, here. You need to realize that because alpha is obtuse, then because we're in the S quadrant, cos alpha will be negative and sine alpha is positive. So that was a very important bit of information. Okay, next, simplify 5 sine theta cos theta. Okay, that kind of looks like the 2 sine theta cos theta. So if I took 5 out and put 2 cos theta sine theta in there. Oh, sorry, I switched them, but it doesn't really matter. They're not equal anymore because I put a 2 in and there wasn't a 2 before. So I also need to kind of divide by 2 to cancel the 2 out. And now I'm going to take that divided by 2 out here. So that becomes 5 on 2 times 2 cos theta sine theta. But wait a minute, 2 cos theta sine theta is the same as sine 2 theta. So that whole thing just equals 5 on 2 sine 2 theta. Okay, I'm going to write in red to differentiate. All right, so here, this looks a lot like the cos 2 theta rule that says, up here actually, cos 2 theta equals 2 cos squared theta minus 1. But I've got 6 and 3. So what if we take, if I want like this constant term to be 1, I would take 3 out. And I also want this term to be 2, so I would take 3 out again from the 6. So let's just see what happens when we take 3 out. We get 2 cos squared 2a minus 1. All right. Now that looks more like our rule, which is great. So this in brackets becomes cos 2, cos of, now usually we'd just put 2a. What's the problem though? Remember in our rule, I might go up to the original. Okay, so we got 2 theta here and theta there. So whatever angle is in the cos squared theta, when we rewrite it using the double angle rule, this angle should be double the cos squared theta angle. So we don't actually want 2a, we want 4a, because we think, well, what's double this 2a? Oh, that would be 4a. And so that's our final answer.